Hello and welcome back everyone. So in this time we are going to talk about computer networks, what computer networks is, and why do we need to understand its concepts. And we're going to talk also about its models and how things are done within it. So firstly, before anything, let's define something we think that anyone can define, which is internet. What is internet? What is the internet actually? Can you give a definition for the internet? So the internet is usually defined as the computer network that interconnects hundreds or even millions of computing devices throughout the world. So the internet is a connection or a network connected to another network. So let's say this is a network, some things are connected to each other. These things connected to each other are then connected to other things connected to each other, these things are connected to other things, which makes it a network of networks. So it's just sometimes it's called as network of networks. Okay, so this defines the internet. So the next step is to define what is a network even. So a network is a set of devices, often referred as something called nodes. Okay, so what is a node? It's firstly, before we define a node, these nodes are connected to each other through communication links. Okay, these communication links we're going to explain in a different set of videos, because they have different ways of propagating, transmitting, and so on. But for now, we want to talk about the node. What is a node? So the node can be anything that this node can be just a passive device, or there can be something called end device or end edge device. So this can be, for example, a computer, can be a printer, can be any device, or can be a sender device. So that can be another device that can be sending. This can be, for example, be a router, a switch, a hub, and all of these we are going to talk about. So a node can be an end device, or can be a sender, receiver, or receiver. Yeah. So this sender receiver can be side as TX RX, like transmission TX, transmitter, and receiver RX. So in turn, these connection to things, we are going to talk about each of these things. So before we talk about about any of these, there are different names we know, like in the internet, things like something called DSL, something called Ethernet, something called Wi-Fi, something called 3G, something called LTE. All of these are computer networks we are supposed to talk about in our videos, or on our understanding for this computer, or in this course of computer networks. And we are supposed to understand each one of them and its boundaries. So before we start, there is some ways to draw devices. So if you want to draw a PC, you can just draw a PC, like you can draw something like that. Okay, just a PC, however you would like to draw it. Okay, so but there's some other things, like this is, let's say this is PC. This can be something else. It can be a server. So a server, you usually draw it like a big rectangle like that. Okay, this is not the thing I want to talk about. It can be a server. A PC is a server, or a server is a PC, but the server has a capability of being centric, like is a central PC that does tasks, does certain processes. Okay, does certain processes or services for the other PCs. So it can be normally a personal computer. Okay, it does services like DHCP, TCP, DNS, and these services It's provided by the services and even the web services. There is server and there is a router. The router is usually defined as this structure, something like draws like this way. Okay, it's drawn like this. It's like a circle or like a, yeah, it's like that. And this is a router, and or it can be a switch. So a switch is something that looks like rectangular like this. This is a switch. So these are various devices in our system that have different architectures and have different uses, and we need to understand each one of them. So each one of them is on a certain layer, or is used on a certain place, in a certain place. So all of these, of course, we're going to talk about in our course. Something else, like why we do why do even the characteristic of network communications. We are supposed to find that we want to deliver the message correctly. So we want a good delivery. So we must deliver the data to the correct destination. Supposed from the right sender to the right destination. Okay. And they must be received to the intended device or user. Something else is the accuracy. So accuracy is the data shouldn't be altered. So the altering of data should not be possible, should not happen. We shouldn't alter the data, should be as it has been sent. Something else is called the time. Something else we want to talk about is timelessness. Timelines. Okay, timelessness. Okay, so the thing is, I want to make it in the delivery time as low as possible. Delivery time, yeah, time. And something else I want to increase or decrease. Something else I want to decrease is something called the jitter. The jitter. There is a difference between the jitter and the noise. Okay, the noise is, let's say this is my signal of voice. This is my voice signal. Having noise, the signal becomes distorted. Yeah, it just becomes like that, shaky, destroyed. Okay, this is noise. But a jitter is like the message came late, so it's supposed to start at T0 or like at certain time. Like I just said something, it comes late. Yeah, or just comes incomplete as late, or so on. Yeah, so this is jitter. Yeah, this happens through different problems regarding the transmission. So these are things we are trying to overcome in computer networks. And to talk about the computer networks also, we are supposed to understand that this system, there's something called communication system. Yeah, system. So this communication system is based upon two devices. Let's say it's device A on device B at the simple form. So device A sends, so device A is called TX or transceiver. Device B receives, so it's the receiver or RX. Okay, so this is the sender, and this is receiver. Yeah, this is sender and this is receiver. And something about these, that there is a connection medium between these. So this is called the line between both of these is called transmission medium. So this transmission medium is a research by its type. It's even more complicated than the course of this. We can talk about it, of course, but there is transmission medium that can become either guided, like a line, like cables, for example, or can be unguided, like the wireless. Yeah, unguided, usually called as wireless. Okay. So A and B, A can send to B on a guided path, or can be on an unguided path, like just sending a wave, yeah. And something regulates all of this is called a protocol, yeah. So a protocol must be defined. What is a protocol? So a protocol is usually people say it's a language, and I find this language, and I find this explanation as wrong. Protocol is not a language. Like, they can look at JSON and they say, yeah, that's a protocol. That's not a protocol. JSON is not a protocol. Yeah, JSON is a common language, for example, between two programming languages, or between two applications. But it's not a protocol. HTTP, for example, is a protocol. What is a protocol? A protocol is a set of rules. That's what defines a protocol. A protocol is a set of rules that says for the device A and device B how you should interact with each other, how you should greet. Like A sends to B, A says, for example, let's say says hi, so B says hi back to it, hi. Then they can start sending messages, data 1, and they say, and this confirms that data 1 has been received, yeah. So this is, for example, a protocol. This is a protocol that happens, of course, in TCP. Well, TCP is a certain type of protocol, transmission control protocol, that happens on one of the layers that we're going to talk about in the OSI model. What happens here, that A checks that B hears him, so he just makes sure, so he happens to open something called the handshake. After he does that, he sends the data, and B confirms that this data was sent. All of this is a type of protocol, yeah. This is a type of set of rules that we should handshake, then we should finish, and after we finish, we say finish one. Are you finished? Yes, he says, yeah, back to it, yeah, I'm finished. Okay. So that is a protocol. That's what defines a protocol. So it's an order of message exchange between two or more communicating entities, as well as actions taken on the transmission and receive for the messages. Okay. So there are some performance measures and reliability, like performance measures that we care for. It's like performance and reliability, and of course security. So performance, we want the transmission time to be low, transmission time, yeah, and we want the response time to be high. We want it to respond quickly. We want like a good transmission medium capable of long distances. We want high speeds, high bandwidths, and so on. So as after this introductory, we can visualize this network as layers or a model. This model, the first model, will make up people sometimes confuse something OSI and TCP, that the OSI is before TCP. No, TCP is first. TCP IP is the first model we're going to talk about. It's before the OSI model. So TCP IP model says that it sometimes it represents the network as 4 or 5 layers. I will give with the simple one the 4 layers. So the first layer, which is layer 1, 2, 3, 4, from down to up. So this one is called host to network, yeah, and this one is called internet. Then this is transport, and this is application. Okay, this is application. So what happens here is that let's look at for instance at our web page. A web page or Chrome or Firefox, or for instance, is an app. Yeah, it's on the highest level here. It's on the app level. If we want to download something, for instance, we are supposed to transmit or transport these files and folders. So these files and folders usually be transmitted on TCP or UDP. We are going to talk about these in another video, in the transport video, but for simple reference, TCP makes sure that the packet is segmented and it makes sure it's sent, but UDP, for instance, is for videos. Things that send quickly. I don't care if a pixel on the video fall, or a jitter happen, or a noise happened. A video is a video. Just go on. Especially not videos, but more in streams. Like if a stream cut for a millisecond, no one cares. Like just go on. It goes on. It doesn't need to send back this message. This is UDP. TCP is sending, like you want to have a big folder, 10 gigabytes or something. Yeah, so this folder, I want it all to be sent, each single file, each single bit. Yeah, so these are different protocols and transmission. Then there is internet, and this contains something called ARP, RARP. All of these we are going to talk about in the internet time. ICMP, there's also IGMP. And there is host to network. So that means that this is the internet. This transport that TCP happened on the internet, yeah, and then it became transmitted on this internet through a network until this network reached a host. So the smallest or the lowest layer in the browser or the Chrome or the web is the host. He's the receiver down there. He's just a node in being connected to this huge application, which is an app. Yeah, so that means that the TCP IP stands for Transmission Control Protocol Internet Protocol. TCP IP, Transmission Control Protocol Internet Protocol. So when a message is trying to be sent from A to B, and this message travels by headers. What does that mean? So it passes first, what we have said, the first layer is app, then there is transport, then there is network, and there is also a link, data link, and there is physical. And let's name them 1, 2, 3, 4, 5. This same stack, it also exists at B, so at 5, 4, 3, 2, 1. So when I want to send something from my firewall or from my Chrome or from my whatever, and the app layer, it goes to the transport, then it goes to the network, then sends to the link, then to the physical, then on the physical line on my cables goes back to the link, goes back to the network, then back to the transport until it reaches the app layer for the other user. But in order to know which app I have used and which transport I have used for the network, and the network which knows what layer, what the data sender receiver it used for the link, it adds on each step plus header. It adds a header. Okay, so this adds header 1, this adds header 2, for instance, this adds header 3, and so on. And then when we come here, we remove this header, so minus header 4, yeah, so it just removes each header step by step. Okay, now this wasn't the complete model. So TCP/IP was here simple on 4 layers. It happens here to be even more segmented. After like 14 years from the development of TCP/IP, the OSI model came out. So the OSI model states that this is OSI model, open system interconnection or something like that. It's has open yeah. The idea is it dissects all these layers into even more shown ones. So here is the first one. Let's draw it quick, better. So let's say the first one is application. This is the first one, or this is the 7. Okay, like this is the highest level, like the other one. Then there is the 6. The 6th one was now let's say 5, 6, 5, 4, 3, 2, 1, 3, 2, 1. So yeah, so the highest one was application, the lowest one is gonna become physical. Then there is the data link, there is also the network, there is the transport, session, and the presentation. So as the TCP/IP, this application is the layers that all of these upper layers, these are called the upper layers. From 5 to 7 are called upper layers. They send data. Okay, they send data. Physical layer, which is the cables, which is the Wi-Fi, which is the wireless, sends bits. Data link sends a bunch of bits together, they are called frames. The network sends a bunch of frames together, they are called packets. Okay, these 3 layers are called media layers. Then there happens to be sent on transport. This transport is a bunch of packets, or the packets next to each other are sent to be segments. These 4 upper layers are called host layers. So what are even these layers? So physical layer is manages the cables or the things that are physical, like goes on the electricity level, like binary 011, yeah, binary, yeah, just binary. This is the physical cable, electricity. Data link is manages something called the MAC address. It's a unique address for each device. It's also still kind of physical. It's also called physical link for physical address. And some manages something also called LLC, but it's out of the course right now. Or out of this, we're gonna talk about it in the data link video. There's the network. The network is a higher level. So after it goes from the cable, it goes here to have the devices here have names, which is MAC addresses. These MAC addresses, we want to get them out on the internet. So get them out of internet, we need an IP. So yeah, IP is in the network layer. After we have defined an IP to get on the network layer, we want to know how we're gonna send this, like how we're gonna send it. Is it a stream, or is it making sure that the sender is the true one, the receiver is the true one? We want to make sure that everything is alright. So here we have the TCP IP, TCP and UDP, like the one we set up there. Then the session, presentation, and the app. Sometimes they just mixed all these 3 to be app, but in the OSI model it segments each one of them. So session is like, let's say on the simple spectrum, let's say like I've opened a multiple Chrome tab. These are multiple sessions. Yeah, it's the simple way to explain the session. Multiple Chrome tabs. Presentation is like .exe, for example, let's say .iso, whatever, bin. Yeah, so these are presentation. These are the headers for the file that define it, or sometimes they're called metadata. And this is the app. The app layer is like the firewall, the Chrome you see in front of you, the web interfaces and the web apps, and so on. So this is the OSI model, and this is the introductory to the computer networks. I hope it was rich and useful. If you liked it, please like the video and subscribe, and I will be making more about each of these layers more in detail. This video was a little bit more taken out because like I couldn't talk about really too much because it's the introductory, but in the next videos I'll be making sure that these topics are covered. And thank you very much for your time, and bye bye.